Childhood developmental disorders are problems that children are generally born with. Sometimes they're physical problems, often they're problems, sometimes very serious, having to do with brain development and mental problems and development of things like language and other processes that children normally go through in their development that are delayed. Not always, but many times, these disorders are due to some problem with the genes, and they're genetic. They have a genetic basis. And sometimes they can be due to a problem with a single gene. An interesting thing is we know the causes of many of these disorders. There literally are many thousands of them. We know the causes of several thousand, maybe 3,000 or 4,000 of these. Many of them are rare. Some of them are disorders that we have all heard about: sickle cell anemia, cystic fibrosis, many others like that. And even though we call these childhood disorders, many times the children with these live a normal lifespan and have these disorders for their entire lives. So it really requires often lots and lots of resources and time and effort and real challenges for both the children who are born with these and their families and their physicians.
20 years ago, I was a graduate student in a university that had a medical genetics department. And we saw patients, we saw families that brought their kids in that had some set of symptoms that they wanted to try to find answers for. And the technology that was available at that time, in many cases, meant that we gave parents an answer of, we don't really understand what's causing this set of symptoms. But we hope the technology will advance enough over the next few years that at some point we're going to be able to give you that answer. Today, I think we're on the threshold of being able to give families those answers that they have sought for so many years.
Once we get the results from the genetic analysis, then we need to do something with that information. But then there are a lot of issues about how you use that information. Do you just tell the patients and their families? Do you tell the physicians? How do they interpret it, especially for an unexplained disorder? So we have a genetics counselor working with this full-time, and Martina has people in her clinic who understand all the issues about how do you deliver this kind of information back. This is really new. It's very cutting edge and really important that we understand that.
This project is really exciting because it's one of the first examples of the genomic research that goes on here at Hudson Alpha being used to help provide information back to the patients in our community. When you open up a genome and look at it, you're going to find not just a specific cause for disease that you're looking for, but you may find other things, such as a susceptibility to cancer or the fact that an individual is a carrier for some recessive condition. Other things that maybe aren't important for the disease at hand, but may be medically actionable and something that the patient might want to know about. And so figuring out whether that's information patients would want to know and how they want to receive that information is an important part of the research we're doing as well. Getting a genetic diagnosis may or may not bring about a change in how a child is being treated medically. However, there is still huge value in being able to provide a long-awaited answer to a family about the cause of their child's illness or symptoms. It can also help a family get a clearer picture of what that condition may look like over the course of their child's life. It is certainly our hope that the information we learn from this research project will be able to provide valuable insight for the scientific community about the causes of developmental delay and other childhood neurologic conditions. But in addition, we hope that we're going to be able to provide meaningful results back to our patient participants, and for some, finally be able to answer that big lingering question of why.
It is really hard to see a loved one suffer from a disease, and certainly all have experienced that in one form or another. But it's particularly poignant and particularly important to us when a child is born with a disorder and the challenges that both the child and the family faces on dealing with that. This is a problem everywhere. We really haven't had the tools to understand this at the levels that we would like to be able to understand, and feel that this project is a good way to start charging into this in a big, big way. We want to have the biggest impact we possibly can and do as much as we possibly can for these children and their families.
there's so much of the work that I do works in working with geneticists and researchers, because I mean the research is so important. To get all this information is so important. But and everybody's out there. That's the choir. We're out there working so hard. But it really is to make sure, who are we working for? That we see the face of that kid, that person that we're doing all this research, whose lives we're trying to improve, whose kids that we embrace and accept. That we always want to put that face out there first and foremost. Never, ever, ever to see a disease or diagnosis, but a human being first and foremost. And the beauty of this is that to bring all these incredible stuff here at Hudson Alpha, where there's so much research going on in genomics, but it's all boils right down to Sarah. It boils right back down to Jen or to Aiden, to Will. These are the kids. It's Beth and it's Brandon. This is the hope. This is why this building is here, to exist for to house hope for these gorgeous kids.